Righty-ho, part two. The eagle-eyed amongst you would have noticed, so this cover's just resting back on there, a couple of screws just to keep it covered over while the rest of it's in bits, and this as well. Do those screws up a bit more maybe. So the eagle-eyed amongst you would have noticed when I pulled that clutch cover off, there's no clutch cover gasket. That is the reason that kickstart's tight, so the shoulder on the shaft is binding on the cover. The thickness of the gasket is just enough to give it a little bit of relief, a bit of running clearance. So anyway, so that's an easy fix. One bit of good news. Let's go with the good news first. So the second bit of good news is the crank all seems good. All the small end bearings are okay, so that's all good. Let's take you over to the cylinder head. Right, okay, cylinder head. Good news with the head. So don't know how well this is going to come out of camera, probably not in this shot, but the faces of the valves aren't worn particularly. The valve guides are lovely and tight. There's nothing in the valve guides. It's remarkably good actually. So I'm going to vapor blast everything and the valves, clean everything up, lap the valves in. I might just touch the valve seats up possibly. Valve stem oil seals, and I think the head's going to be good to go. There's not a lot to do. The bearing journals, because as you probably already know, the cam runs directly in the cylinder head, but the journals look really nice. There's visibly some tiny score marks, but you can't feel, you know, that it's fine. You can't feel the marks with your fingernail. They're just, yeah. So that's all good. The cam followers are also pretty good for one of these. There's slight bit of, not wear, but you can, you know, there's running marks, but that's all good. But the issue we've got, and I've seen this before, the camshaft, I might try and get you a better picture and just insert in the video, but the top's just started to come off the lobe. It's on one of them. Some of them are fine. This one particularly is quite worn, and it's just coming through the hardening. So it's going to need a camshaft, which is, fucking hell, where are we going to get a cam for a 404? I don't know. I mean, it would run on this. It has been running on this, but in terms of longevity, you know, it's not the right thing to do. Wants a cam in it, really. And ideally, if you put in a cam, this is what happens. It snowballs. You put a cam in, really you want to replace all the followers as well. I'm going to see what parts are available, see what I can get, new or second hand, in good condition. But that might be the sticking point. And then let's move on to the barrels and pistons. So, get rid of that. Barrels are really, really badly glazed. Again, I'll insert picture here. Barrels are really glazed. There's some rust marks in the bottom of one of them. It's obviously sat at some point with a little bit of water in there. There doesn't feel to be a massive wear groove. So what I'm going to do is I'm going to run the honer down it, deglaze them, give them a clean, and then we'll do some actual measuring once they're clean. It's just so much easier. You know, with measuring equipment, you don't want minging hands and filthy dirty parts. So I'm going to hone these lightly, just deglaze them, get a nice crosshatch back in them, get them cleaned off, and then we can do some proper measuring. And then forget one of the pistons. I haven't measured anything yet, but the pistons, and this is really common for these, the rings basically lose all their energy. There's literally, you can, with the lightest of touch, you can push the ring all the way into the body of the piston. So that combined with really glazed cylinders, that's where your oil burn is likely coming from, given that the valve guides and everything are in really nice condition. But there is quite a lot of wear in the ringland, so can we see, I don't know whether we can see that, but we might end up, just depends how the cylinders measure. If the cylinders measure almost perfect, we'll probably end up with pistons and rings. I think these are probably standard, but we'll measure. So there's a bit of cleaning to do now, and then we'll do some proper measuring, see our oval out around the taper, what's it, the bores are, measure the pistons, and then we'll start compiling, that's not even a word, compiling, fuck's sake, compiling. I'm due a coffee, my brain stopped working. We'll fucking hell, speak properly. We will compile. Are you having a fucking laugh? We will compile a parts list of all the bits we need. Gaskets, seals, blah-de-blah. Right. Let's do a load of cleaning, which I won't show you because it's boring as shit. And then I'll bring you back in when we're doing some measuring. Happy days. Okay guys, right. Quite a lot has gone on. And I apologise for the changing camera. You're not getting any of those arty shots for the rest of this video. This camera's just easier to use, etc, etc. And I've got my head down and I can barely bring myself to film this, to be honest with you. I've got so much going on, and yeah, because there was a part 1 to this video, which I'm assuming you've seen. So I feel like I have to make part 2, but it's really balls to the walls here at the moment, and I got to get filming. Got to get filming, got to get working, so I'm using this camera because it's super easy. So quite a lot going on here. All the bits have arrived. Got gaskets, got some new, you'll see it as it goes together. Got 4, so the old ones vapor blasted okay, but the ones you see on the outside, I've got 4 new genuine Honda ones for there. Gasket set, obviously. 4 new pistons with rings, with new wrist pins, gudgeon pins. The Cerakoting's all done. Oil seal for that cover there. Got a gasket for that cover. There's the bits for the clutch mechanism. They got to go back in that cover. New valve springs. Might get onto testing valve springs in a little while. Just, yeah, they suffer with weak valve springs. I've said that out loud already, but I'll do a comparison between a new spring and an old spring. Now then, you know I always say every day is a school day. Well, apparently it is, because I learned something. So I've had this camshaft. Remember how shitty this camshaft was, how the lobes were done? I've had this cam reground. And I've been down a little bit of a rabbit hole learning about this. So I was always taught, and I was always led to believe, that the hardening on a camshaft was only sort of, I don't know, 10 thou thick. And once you got through that hardening, you were done. Well, actually, that isn't true, apparently. So all these cast camshafts, they're induction hardened, which is just a posh way of saying they're... I've been down a rabbit hole trying to learn about this subject, because it's not something I knew much about. And if you want to lose yourself for a few days, go and research metal hardening on Google, because it's a bit of a subject. Induction hardening simply means that the way they heat, so this is cast as a blank before it's ground, and before the profile is ground onto the cam. So they cast the blank and then the machining's done afterwards, but they're hardened before they're ground. So what they do is they get the blank, and the induction, it's induction hardened, which simply means that they heat the cast blank using, go and look it up, induction heating method, which just is an AC magnetic field that they use to heat up the blank. It's just because this is conductive. I won't get into it, but it's heated up and then it's quenched, which gives it a hardness. Now, fucking waffle, sorry, I was always led to believe that the hardening wasn't that thick, but that's a complete lie. I spoke to the guy that ground the cam, and he told me exactly what my research led me to believe. About 200 thou thick, so crikey, you know, right into the core of the camshaft. So they induction harden the cast blank before it's machined. Insert a picture here of a cross section of one of these camshafts cut open, and you can physically see how deep into the core of the cam the hardening goes. So anyway, waffleage, this has been reground, it's been tested for hardness. I do have some little hardness testing files, but I lent them to somebody a long time ago and I never got them back, which is slightly annoying, because I went to look for them just so I could do a very rudimentary, you know, hardness test. Can't find my files anyway. But after it's been ground, hardness has been tested, it's fine. So that's that. That's done. This head doesn't have its valves in yet, so I need to lap the valves in. I've got new springs and I've got new valve collets and all sorts of stuff to build this head back up. Probably won't show you much of that because I really need to get on. New pistons and rings. These cylinders have been honed. I've had a measure. It's all fine. I might just maybe quickly show you some measuring, how I do piston skirt clearance measuring. Shall I do that? I'll show you that quickly. I've got to get my hand out of the shot because it focuses on my hand. I'll show you a little bit of cylinder measuring really quickly, try and make it interesting. If you want to sort of deep dive on cylinders, go and watch, I'll put a link here, go and watch the GSXR 750 engine build series of videos. I think there's like 7 parts. I go right down a bloody rabbit hole with that. So if you want more info, go and watch that, because the principles of this stuff, it's all exactly the same, no surprises. Right, piston skirt measuring, piston skirt clearance measuring. Okay guys, cylinder measuring. I'm going to try and make this as quick as possible. I keep saying it, Don, I need to get this job done. I'm not a YouTuber, I'm a jobbing motorbike mechanic, and yeah, every second spent in front of a camera is money I'm not earning, so bleeding heart and all that. Measuring cylinders. So you're interested, and I've said it before and I'll say it again, up in this corner here is a link to some other videos, GSXR 750 engine build series. I think there's like 7 videos in that series or something. You want to know granular information, maybe go and watch that, because I talk about it way more in that. I just wanted to give you a little bit of an overview of what was going on. We're interested in whether the bores have taper or ovality, and without going down a massive rabbit hole, I use a digital bore gauge for this. I used to use analog, but I swapped everything over to digital a few years ago. These are great because you can do a minimum sweep. So if you hit the minimum button, you put it in the cylinder, you rock it past and it picks up. Are we getting that? 55.1, what did I measure it at? 4.8 when I measured it before. Let's go again. Slightly further down. 50.049, you get the idea. I've got the size written on there. So that's that. That's handy to be able to just pick up the minimum. And then the other thing you can do, which I like with a bore gauge, shall I show you or not, is what you can do is you can get your piston size and basically zero this gauge out at the piston size. So then when you do your sweep, it's literally reading off piston skirt clearance. I might do that in a second. Let me just waffle a little bit more about cylinders. So I've measured all these. There's like 0.2 of a thou difference from, yeah, there's a couple of tenths of a thou where ovality in them, which is nothing for one of these. They all measure absolutely fine. So you'd measure in 6 different places. So you'd measure at the top of the cylinder, the middle of the cylinder and the bottom of the cylinder, and then you'd also measure this way, middle, top and bottom. Does that make sense? Sort of get an overview of your cylinder size, whether there's any taper or ovality. Now, have I said already? I don't know. These cylinders have been honed with a 180 grit silicon carbide. I nearly said aluminium oxide then. A 180 grit silicon carbide flex hone. Do you know what a flex hone looks like? I think you probably do. I'll show you one. This is a flex hone, not the right one for this engine, but yeah. So why am I showing this? People hate these things. People bitch and moan about flex hones, and it's because I don't think they understand what they're for. You're not removing any taper or any ovality out of a cylinder with one of these. That's not what they're for. You need a rigid hone for that, which is a whole nother conversation. it's a surface finishing tool. That's all it is. It's just for giving you a plateaued cylinder wall finish, and done correctly, honing at the right speed and the right amount of jiggery pokery, you get a perfect crosshatch in the cylinder wall, which is exactly what you need. Again, I talk about that in way more detail in the G6R series of videos. Let me just set this up so I can read off piston skirt clearance for you, show you that. I worked it out with this. I'll just do your number 1. So this piston measures at 50.997. The cylinder measures at 51.048. Just did it there. So hang on a minute, 99. Oh, that must be the other cylinder. Oh, that's the other cylinder. That's this one. So the piston measures at 59.94. This bore measures at 51.048, which gives us a 54 micron, which is 2 thou, give or take, skirt clearance. So that, yeah, that works out perfectly. And the others are within a couple, 0.2 of a thou, the same. So that's all fine. I think I'll probably leave it there because I just don't want to make this video longer than it should be. To save you commenting, yes, it's flat. I've had a straight edge on there, and and it's not just it's a proper machine straight edge that's like it's a what is it? It's 1.5 foot long, and it's ground to within a couple of microns end to end, so you can get a real good, again, G6R video, go watch, talk about that. Everything's flat, everything's clean, piston skirt clearances are correct. What should I was just thinking, end gaps on rings. It's worth, I can't remember the last time I ever had to adjust an end gap on a piston ring. If when you buy a piston, the piston skirt clearance ends up being correct, almost without exception, your end gap in your ring is going to be fine. It's probably worth just putting a ring down the cylinder, putting the piston in to true it up, and just measuring, just for just for sanity's sake. And I know the other thing I wanted to show you was how much difference temperature makes. Right, stand by, I'm going to do a little experiment for you. Okay, before I show you my little experiment, I just wanted to show you this. So this bore gauge is now set to, how to explain, so when it's reading 0, it's actually 50.997, which is the size of this piston, which then means that when you do your minimum sweep again through the cylinder, it's going to read off what the piston skirt clearance would be. Does that make sense? So if I do this, I've got minimum sweep turned on, yeah. 48 microns. I mean, it's not quite the same as my calculation, but that's why I prefer to do it this way. There's 2 lots of how to put this. You measure in piston diameter and you measure in cylinder wall diameter. There's 2 opportunities for a bit of an error there. So if you do it this way, let's go again, let's see if we get a different reading. Oh, didn't minimize it. Yeah, it's the same. One more time. Let's try lower down in the cylinder. Because what I've done, I should probably tell you this as well. So the bore diameter, there are ever so slight differences, only a couple of microns from top to bottom, but you average them out, if that makes sense, to come up with this number. Let's try lower down. See, I'm getting 5.7 there, 57 microns. I worked it out at 54, and if I measure at the top, it's slightly the other side. You get the idea. Splitting hairs. Let me show you my little experiment. So we got 2 thou of skirt clearance, which I should probably say as well, I may not have said already, but these are aftermarket pistons. These are particularly good actually. What have we got? We've got a 996, 993, 994, 997, so there's not a lot of difference in size. Some of these aftermarket pistons, it's a little bit of a lottery. There can be, you know, almost half a thou difference, believe it or not, between some of them. So then you can, have I said this already, if you've got slight discrepancies in bore wear, you can sort of musical chairs your pistons around and get your best possible clearances. Does that make sense? Of course, in an ideal world, you'd bore it, you'd put new pistons in, it would all be, but you know, it's gonna be fine, saving the customer a ton of money, not boring it, you know what I'm saying? Because this is just a bit of a refresh. It was running perfectly, really, a bit down on power. Actually, that's not true, it wasn't running perfectly, it was a bit down on power. It was a bit smoky, bores were glazed, I think we talked about it, didn't we, in episode 1, possibly. I just wanted to show you, this is my experiment. It's about 10 degrees in the workshop here at the moment. I'm just going to put this piston in the Cerakote oven and warm it up and show you how much temperature makes a difference to when you're measuring components. You'll be surprised. Editing Jim here. I just been editing this and realised that I'm using metric and imperial measurements together with one another, and it might be a little bit confusing, and I apologise. I think in my brain, I'm not quite sure why, I visualise in imperial measurements, like in thou. So if I'm talking about a piston skirt clearance, I'll be talking about, you know, 1.5, 2 thou piston skirt clearance. But when I'm doing my actual measuring, I'm measuring in metric. So I apologise if it's confusing. Just remember, 25 microns, give or take, in a thou. Okay, not quite sure how well this is going to come out on camera, but 4 pistons. Number 1 over there is, are we getting that? What's that? 12 degrees on the skirt there. It's hotter. 18 there, 22 maybe. So it's nice and warm to hold in your hand. And then the one next door is 7, 8 degrees. Anyway, that's enough of that. You don't want to see that. Just want to show you this. So this this piston measured originally at 50.997. Okay, and now it's warmed up a little bit. This is so difficult to do. If Mitch or Toyo are watching, can I have some new micrometers, please? The issue I have with these micrometers is when you turn this bit turns. The really posh Toyo ones, yeah, that doesn't happen. They're great micrometers, these, though. They came from Digital Micrometers Limited, if anybody's wondering. Yeah, we're about... It's grown by about half a thou. Isn't that incredible? Don't you think that's incredible? That, I mean, you obviously can't feel it. That one feels cold to the touch. That one's been on a radiator for 5 minutes warm. Do you know what I mean? Why am I telling you this? So, if your cylinders were in your cold workshop and you kept your pistons in the house and you think, oh, I'm going to go and do some measuring, you take them outside to your garage, start measuring, you're fucking way off with your measurements. You know, mere mortals like us, we can't afford climate-controlled engine build rooms, which is what the big boys use. And there's a reason. You want all your components at the same temperature. So to negate this, make sure your barrels and your pistons are, you know, have been in the same environment for a few hours, so everything's at the same temperature. That way, you know, your clearance measurement should be somewhere near right. Interesting, hey? Right, gonna lap some valves in. Got to put the rockers and all the other bits and pieces back in that camshaft cover. I'm going to do that, and then I might show you just quickly show you valve spring testing, what I really have got to crack on. Right, see you soon. Okay guys, so I wasn't really going to show you this, but I thought I might as well since I'm here and the camera's out. Valve grinding. For those of you that don't know, and I'm pretty sure most of you watching this will know about valve grinding, so use some grinding paste. This is grinding paste. Comes in different flavours. This is the fine variety because not much grinding required here. Let's get the oil off that. And all you're doing is you're matching you're grinding this sealing surface on the valve into the sealing surface in the cylinder head. So down in the cylinder head in here is a seat that this sits against. Great camera work, Jim. And you're just making sure it's gas tight. So you put grinding paste between it, between this surface here, God, what terrible camera work, and this surface on the seat, and you lap them together so they're gas tight. These aren't that bad, as you can see, and there isn't really any noticeable wear on the seat. If the seat's worn, there'll be a sort of slight dish in the where it's been coming into contact with the valve seat. And then what you would do, actually get it in shot, Jim, you'd either reface the valve, so you put the valve in a machine and it spins the valve and grinds a new flat on it, and you reface the seat as well. What did I want to say? Grinding valves, it's a bit of an old school thing now. You don't tend to do it with really modern stuff because they've got titanium valves, and you can't grind a titanium valve. They have a special coating on the face, on the sealing face, and if you grind it off, you're done. So with a titanium valve, you would replace the valve and recut the seat. Anyway, grinding. So as you can see, this is highly technical. So you're basically rubbing the two surfaces, the face of the valve against the valve seat, and if it gets a bit stiff, a little bit of something on it liquefies the paste a little bit. I think my valve grinding paste actually is getting might be a bit old and gloopy. So when you've had a good old grind, what you do is you clean off the valve and you clean the seat and you inspect. I'm not sure how well this is going to come out on camera, but you're looking for a continuous, I wouldn't say shiny, I'd say dark satin grey band all the way around the valve, uninterrupted, and the same on the seat in the cylinder head. That looks fine. What you're after is these two mating absolutely perfectly to create a gas tight seal. That makes sense. And if I can think when I'm editing, I'll flash a little picture on the screen, but the width of the seat is also important. The seat being, hang on a minute, let's get your terminology right. This is the face of the valve, this is the seat in the cylinder head. So the how to put it, I need a diagram really to show you, but the seat should be touching exactly in the center on this flat face of the valve. So the seat would be cut. I'd need to measure it. It's probably, I don't know, 1 millimeter or so wide, maybe a bit wider, and that needs to be resting right in the center of this flat surface on the valve. I'll put you a diagram on the screen because I'm doing a really shit job of explaining what I mean, but yeah, so we have a continuous uninterrupted grey band all the way around the center of this face on this valve. I'm teaching you to suck eggs, I know I am. I'm going to carry on now, I'll see you later. Okay, valve springs. What you need to know about valve springs is they can measure, so this is the old valve spring, measures, what's that, 35 dead, within spec according to the Honda manual. This is the new spring, measures 35 dead. So if you were just measuring your free height of your springs, you wouldn't be getting the full picture. let me show you something. Right, so I've got the valve in the head, I've got the seats, which are the two washers for the inner and outer spring in the head, I've got the collets on the valve and I've got the top cap on, and I've measured, it's hard to film and measure at the same time, but I've measured the compressed height of the inner and outer spring with a vernier. Does that make sense? Hopefully that bit makes sense. So you can ignore my calculations, but what I've worked out is the larger of the springs is compressed 5.35 millimeters when it's assembled in the cylinder head, and the smaller spring is compressed 6.5 mil. So with that information in mind, I'll take you to my press. Okay guys, valve spring pressure testing. So we want to compress this spring 5.35 millimeters. I'm going to read off on this gauge here how much force it's exerting. Is that coming out on the camera? It's not coming out that well, is it? And what you also need to do is, hang on, let's zero this out. Let's make sure my gauge is 0. And let's go. Now, we need to read off the scale quickly because my press backs off. The seals are old. So what do we want? 5.35. Sneak up on it. So this is simulating it being in the engine with the valve shut. What are we getting? 8.9 kilos. Okay, so that's the old spring. Okay, and this is the new spring. What was it? 5.35, wasn't it? Near enough. 11.2 kilos. You understand why I'm showing you this. The free length of these springs, the old and the new, exactly the same. And to hold in your hand, you wouldn't notice any difference. So if you were just measuring free length, you wouldn't pick that up. I won't bother showing you the small springs. There's a similar sort of discrepancy. Can't remember what the numbers were now, but it's a couple of kilos. Yeah, there's a big difference. So the moral of the story is, measuring free length of a valve spring, you're not getting the full story, you're not getting all the information, so just pay attention. Right, I'm going to, all the valves are lapped in, I'm going to put all the valves in, valve stem oil seals, build the head up. Yeah, I'll probably time lapse a lot of it back together. In fact, I think given I've waffled more than I intended, this is probably end of part 2. So I'll see you next week in part 3 for the assembly and maybe a road test. Thanks guys. You're not getting rid of me that easily. Sorry. One more thing. Just getting myself organised to put this head together, and realised I hadn't mentioned something which might be sort of half not interesting but valuable bit of information for you. See this valve spring? See how the coils on this end are tighter wound than this end? This end, the tighter wound springs go to the cylinder head surface, and then the collets and the cap go on the other end. It is goodbye now. I'll see you in part 3.